Yes, students. So, coming to our first topic of the chapter, that is characteristics of a solid state. So, characteristics of a solid state, as we have discussed in 11th standard, that it is having a definite shape. The shape of a solids are always fixed. They don't change their shape unless it is changed through the melting point. Okay, it has a definite volume. It is a very rigid. It is having high density. It is low compressibility. Now again, on one important term, that is low compressibility. We have studied in 11th standard about gases and liquid that they are compressible, right? So majorly compressibility means it can occupy in a very less volume, but it can be in a large amount. Like gas, the gas cylinder, if the volume of a cylinder is same, if we fill water inside it will be having less amount of water, but gas definitely it will be more. Why? Because it is highly compressed inside it, right? But solids cannot be compressed, right? So they are having a very low compressibility. Again, the most important point about the characteristics of a solid is constituent particles are closely packed and held together by strong interparticle force. Means what? The particles, now which are the important particles which can be present in the solid? It can be molecule, atom, or ion, right? So these particles which are present in the solid state are having a definite position, right? And it are closely packed to each other. There is no random movement of these particles inside the solid like it can happen in liquid and in gaseous. When we talk about the gaseous property, that if we are spraying something, it will be moving very fast, right? Flow of liquid, if we are flowing any liquid, if we are throwing any liquid, it will be flowing from its higher concentration to the lower concentration. But solid, if we are throwing, then it will be stuck wherever it is there, right? So means why it is happening? So because its molecule are closely packed with each other and it cannot move, right? And they are forming the definite force with the combination of each other, that is known as an interparticle forces. So again, going through the properties of a solid, it is having definite shape, volume, it is rigid, having high density, low compressibility, constituent particles are closely packed and held together by strong interparticle forces, right? So this was the characteristics of solids. Now as we have discussed in the introduction, that characteristics of solid, after that we are going to discuss about the two different types of solid, that is crystalline solid and amorphous solid. Now in a very layman language, if we want to distinguish about the crystalline solids and amorphous solids, how we can identify? If we are taking a salt, that is NaCl, right? A common salt, a table salt which we are knowing, even at home we will find it very easily, right? So it is of white color, yes. Another, on the contrary, if we are seeing another powder, that is a talcum powder or a turmeric powder or something, right? So if you feel the texture of that NaCl and feel the texture of a talcum powder, though both are white color and both are solid and both are in a powder form, but when we are going to fill NaCl, we will find that it is not so smooth. But on the contrary, if we see the talcum powder or a turmeric powder, that at that time we will find that it is having a smooth filling, right? So the basic difference of the properties of crystalline and amorphous is what? Crystalline substances are not smooth and they are rough actually, and amorphous are smooth and they are not rough. Okay, why this is rough and why this is soft? Again, we are having a different properties of both, and that's why we can distinguish between them. So here I have made a table over here, that is in order to distinguish between them, and also we can see the properties of them. So this way you can remember the properties of crystalline and amorphous very easily also, and if a difference between both of them are asked, you can write down in a form of difference, or even only if it is asked to describe the properties of crystals, you can just remember these points and write down those points. Only if of amorphous, then only write down those points. Okay, so here we are going to study in a comparative way so that it will become easy for you all to understand and to learn it. So as we said that crystalline substances are soft and amorphous are rough. Okay, why they are soft and why they are rough? Because it is having few different structures in that. Now crystals. In crystals, the basic most important example is our NaCl. If we see NaCl, and we have also studied about the structure of NaCl, that it is in a form of continuation, that one Na is combined with Cl, Cl is again combined with Na, Na again with Cl, and same way if Na is here and opposite side it will be Cl, NaCl. So a definite proper structure is formed, a repetition of a unit is there, right? So it is having a definite fixed form, we can say it is having a definite fixed form, NaCl, 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 like that. So it is having a fixed form. On the contrary, that is in amorphous, it is not having a fixed form. It can be in a random manner. It can be in a random manner. If we take any of the example, here we have taken example of glass. So in glass, if you see the molecules of a glass, it may be like arrangement may be A, B, A, B, A, B, A, whatever can be present inside that, right? So it is not having any confirmed position of the particles, and that's why they are known as, they are having as no fixed form solids, and they are known as then amorphous solids. Okay, the next property is long range order. What do we mean by long range order? The same thing as we have discussed over here, that is a long range is there, NaCl, 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 right? And here it is short range. Why it is short range? Because if it is repeating also, that is A, B again, but after that it will be again A, something like that. So the range is not fixed, and that's why it is known as, it is having a short range order. Next is sharp melting point. Definitely it is very clear from the above two statements only that if it is having a long range and it is in order, so when the order is followed at a particular point, it will be breaking down, right? The molecules will be breaking down and it is having a sharp melting point. Thus you can also identify with the help of the practical that we have done in 11th standard. Organic practical, if you all remember, that we have found out the melting point of two substances, that is phenol and resorcinol. So in phenol, at one particular point, that phenol solid was converted into the liquid. That particular point was its melting point, right? So it is having a sharp melting point, so that we can say that it was a crystalline substance, right? But when we consider about the resorcinol is amorphous one. So what will happen? It was always in a range. If you remember that we have written in our practical book also for resorcinol that it may vary from 68 to 75 or something, right? So it is in a form of range, right? So here we see that in crystals it is having a sharp melting point, while in amorphous it is having a range of melting point, that is it may be between some or the other, right? After that, coming towards the main and important point, that is crystalline solids are anisotropic. I am repeating again, crystalline solids are anisotropic while amorphous solids are isotropic. Now what do we mean by anisotropic and what do we mean by isotropic? Anisotropic. So here I have drawn few things, that is the repetition of an elements, that is A, B, A, B, A, B, A, B, A, B, A, B, right? So if we consider any of the property of the substance, consider this as one of the substance. You can consider this NaCl, 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 NaCl. So now if I want to find out the property or the density from this surface, so it will be 1, right? But if I find out from this, then here we are having A and A, right? So definitely a density from here will be different than here. Why? Because here two elements are there, that is AB, AB and AB, but here all will be A only, right? So here the density will be different. Again, if I carry out in a diagonal manner, so again that AB, AB, AB pattern will come. So there will be definitely uncertainty in few of the properties. Okay, there will be uncertainty between few of the properties, and that's why it is known as anisotropic, while in amorphous solid it is known as isotropic. Why? Because as we know that the arrangement in this is very random, A, B, A, B, A, wherever we can find out, right? So what will happen from any side, if we are measuring from any of the side, if we are measuring, the properties will come same. Okay, so this is the difference between anisotropic and isotropic. So anisotropic property is possessed by crystalline solids and isotropic property is possessed by amorphous solids. Here I have also given you the example of the same, that is NaCl, as above also I have mentioned that it will be continuously, right? So NaCl, NaCl, NaCl. So definitely if I am going to measure like this, the property will be something, density will be coming around 76. But if I am measuring horizontally, that is Na will be repeated, right? So again the density, if I am measuring from this side, then it will be different. Here the example is glass. Glass, it is also known as supercoolant cooled liquid. It is exactly not the solid. So if you find out the original glass somewhere which is not polished or anything, you will observe that it will be thinner from the top, and when we move downwards it will be thick. Why? Because few of the molecules are sliding down, and that's why. And that can happen only in a form of liquid, as we have already studied in the above section of characteristics of a solid, that for solid particles cannot move, but in glass few of the molecules are moving, and that's why it is known as the supercoolant liquid, or they are also known as the pseudo solids. They are not the proper solids, and that's why they are also known as the pseudo solids. We have already known what is the meaning of pseudo, that is false. This is the false solid. Okay, so again we are revising very fast about this crystalline and amorphous solids. Solids are basically of two types, that is crystalline solid and amorphous solids. Crystalline solids are having a definite form or a fixed form. Amorphous solids are not having a fixed form. It is having a long range order. This is having a short range order. Here the sharp melting point is there. Here we are having melting point in a form of range. Here it is anisotropic and this is isotropic. Anisotropic means there is uncertainty in the property, while isotropic means having same properties from wherever we are going to measure. The examples are mentioned over here, that is NaCl and quartz. Here example is our glass, which is also known as a supercoolant liquid or a pseudo solids. I hope you all remembered this thing. Okay, now further we are going to study in our new session about the crystalline solid.